Hello again. We're continuing on the 3B notes. I will try to finish through question 5 and then save it and post this. So the first question, actually both of these are review from Unit 1, except this time you get to use a calculator, so it will be a bit easier. All equations, I've been stressing this all semester long, we always do the opposite to move it to the opposite side. If we are trying to solve for x here, what is the opposite of adding 1/2? Well, we are going to subtract 1/2 from each side. Now you need to get out your calculator and just do 4/5 minus 1/2. But if you don't have one, you can work this out. 10 is the common denominator, and you figure it out, and you end up with 3/10. But I do encourage you to have a calculator. If you don't, we really need to try to find an online calculator or something to get you going on this. This one is times 8 over 27. What is the opposite of multiplying by 8 over 27? We can divide by 8 over 27. So I'm really dividing each side by 8 over 27. And again, we can just type this in a calculator to do this. This actually reduces very nicely. Remember, if we're dividing by a fraction, we're really flipping it and then reducing if possible. These are both divisible by 3. These are both divisible by 8. So really it turns out to be 2 over 1 times 9 over 1, which is really just 18. But again, I encourage you to use your calculators. Solving the proportions. As I started earlier, when they are proportional, like the vocabulary number 1, when they are proportional, we really just cross multiplying. So if I cross multiply here, that is going to be 4 times x. Cross multiply the other way, it's 9 times 5. So it's really 4x equals 45. Forgot the equal sign. Now to solve for x, I have to divide each side by 4, so x is equal to 45 over 4. Now it depends on what the question is asking for. Most of the times the improper fraction is fine. If it says a mixed number, then yes, we have to change it to a mixed number, and your calculator should be able to do both of those things. This next one here, we're going to do 5 times n, and we're going to do 21 times 2.5. 21 times 2.5 is 52.5. Remember, this is 5 times n. What's the opposite of multiplying by 5? I'm going to divide each side by 5, and when I do that, I get n equals 10.5. Please pause these at any time to practice using your calculator to make sure you know how to do these things. Especially this next one. You're going to need to pause to practice this one. We're going to cross multiply. Again, we have 4/5 times x equals 6 times 1 1/3. Now, I'm just using my calculator to do this. 4/5 x is equal to 8. 6 times 1 1/3 is 8. What's the opposite of multiplying by 4/5? Dividing by 4/5. When I do that, I get x equals 10. Now remember, when we're dividing by 4/5, we're really multiplying by 5/4. There are several ways of doing this. Please do what's most comfortable for you. Now this next button, you just have to find the button on the calculator. Now most of you should know the square root of 49. Square roots are just something times itself equals the answer. Well, 7 times 7 equals 49, so the square root of 49 is 7. So the question is, what times itself equals 225? You just type it on your calculator, or it is on the multiplication chart as well, but that answer is 15. Usually this button on the calculator is above. They'll usually have like a little x squared button, then they'll have a little square root above it. And it just depends on what color your second button is at the top of your calculator. If it's a TI-30 multi-view, it's going to be in a light blue. If it's in the other one, I think it's orange. But there's the pink calculator, the blue calculator. They have all different colors. But really, you had to hit second, then the x squared button normally. Please find it on your calculator. Find the length of a right triangle whose legs are 5 feet and 12 feet. Scoot this up. On these, I like to draw the picture. Drawing my right triangle. Sorry about that. Here's my right angle. The hypotenuse is what we're missing. Remember, the hypotenuse is always opposite the right angle. So this is C. And the legs are always A and B. And the A and B are interchangeable. If you remember the Pythagorean theorem from earlier, it is A squared plus B squared equals C squared. So now the legs are both A and B, so I put those in. So A is equal to 5, B is equal to 12. So I use my formula here, so it's 5 squared plus 12 squared equals C squared. Now my calculator, I got to work this out. 5 squared is 25 plus 12 squared, which is 144, is equal to C squared. If I add those together, I get 169 equals C squared. And again, like all my other solving equations here, I have to do the opposite. Well, I have C being squared. What's the opposite of squaring something? Well, it's square rooting something. So 13 is equal to C. And I guess it won't write on the line. That's interesting. As you can see, I'm learning how to do this as we go as well. The next one here is going to be finding the length of the triangle here, where we're doing 51 meters is the hypotenuse, and the leg is 45 meters. So I'm going to draw my triangle again. My right angle's here, but this time the hypotenuse is 51. So that means C is equal to 51. Then I have A equals and I have B equals. Again, the legs, it does not matter which one I put it under. I'm just going to let B equals 45. I could have easily just made A equal 45. It does not matter. When I solve for this, it's A squared plus B squared equals C squared. A is what I don't know, so I'm just going to leave that as A squared plus 45 squared equals 51 squared. Now, I've already worked this out, so please don't be impressed. I do not know these off the top of my head. 45 squared is 2025. 51 squared is 2601. Again, how do I solve for A squared? Well, we got to get rid of the plus 20, so we got a minus 2025. So then I end up with A squared equaling 576. Again, we always do the opposite. What's the opposite of squaring? Well, I'm going to square root each side. Then I get A equals 24. So this missing answer over here, A equals 24. And now that's about 8.5 minutes. I'm going to take a break, and then I'll be doing the other side of the notes.